adding and or subtracting rational expressions as well as simplifying complex fractions. Okay, so if we are adding or subtracting fractions, because we need a common denominator. That's really what it boils down to. Need a common denominator. Common meaning same, need a same denominator. They're not speaking the same language until their denominators are the same. Now, how can we tell if the denominators are the same or not, and with the least amount of work possible? We need the denominators in factored form so we can see what parts they already have in common. So, for example, x squared minus 1 can be factored difference of squares, x minus 1, x plus 1. The denominator here, x plus 1, does not factor, but it is x plus 1, and the denominator on the over here is x minus 1. It does not factor anymore. But we can see that there are some common parts to the denominator already. So, for example, the middle fraction already has an x plus 1 in common with the left-hand fraction, but the left-hand fraction has an x minus 1 that is not in the denominator of this middle fraction. So to have a common denominator, it needs to have an x minus 1. Now, you can't just randomly multiply the denominator only by the x minus 1. That would be changing the value of that fraction in the middle. But if I multiply the fraction by 1, I'm not changing the value. So if I multiply top and bottom by x minus 1, the same thing, I'm really multiplying by 1. It's not changing the value of the fraction, but it does change its appearance. And it's got a common denominator now with the fraction on the left. The furthest fraction to the right has an x minus 1. Well, the two fractions on the left already have a common part of the denominator, but it's lacking an x plus 1. So again, you have to multiply top and bottom by the missing part so that you're not actually changing the value of the fraction. Okay, so do they have a common denominator now? Yes, they all have an x minus 1 times an x plus 1. So we have a common denominator. And so we have x minus 1 times x plus 1 for our denominator. Going to combine them to a single fraction right now. I have x squared plus x times x minus 1 plus x times x plus 1. Okay, now you can't leave it like that. We do need to clean up the numerator. We need to see if we can reduce this. The denominator is already in factored form. The numerator is not in factored form. So I do need to go ahead and multiply out and then combine like terms. So we have x squared plus x squared minus x plus x squared plus x all over x minus 1 times x plus 1. Combining like terms, we can see that we get 3x squared over x minus 1 times x plus 1, and that does not simplify anymore. Now, could we multiply out the denominator? Yes. X minus 1 times x plus 1 is x squared minus 1. Do you have to? No, you don't have to multiply it out. So you probably just leave it like that. Problem number 2. 6x minus 5 over x minus 3 plus 3x minus 8 over 3 minus x. Okay, so adding, subtracting, common denominator. Now it's good to pay attention. Notice the x minus 3 and 3 minus x, they are opposites. And so I don't need to multiply the fraction on the left, top and bottom, by 3 minus x, and the fraction on the right, top and bottom, by x minus 3. I can get these to be the same denominator if I can factor out a GCF of -1 out of the denominator. Another way I could get it to be the same is if I multiplied the top and bottom by the same thing. So if I multiply the top and bottom by -1, -1 over -1 reduces to +1. I'm not changing the value of the fraction on the right. But if I go ahead and do that and then distribute the -1, we get 6x minus 5 over x minus 3 plus, now the denominator here for the fraction on the right is now -3 plus x, otherwise known as x minus 3. And here in the top I have -3x plus 8. So when you have opposites like this, we can very easily get the denominators to be the same. And so now the denominators are the same. We can simply add the two fractions. The denominator is x minus 3. I've got 6x plus -3x. I've got -5 plus +8. Okay, it is a fraction. If we can reduce, we need to reduce. Don't reduce unless you're in factored form. So the numerator is 3 times x plus 1, there's a GCF of 3, so 3 times x plus 1 over x minus 3. Any common factors? No. Any opposite factors? No. So it's either this, or we could have left it the way it was. 3x plus 3 over x minus 3. Either one of those two would work. Okay, moving on. Problem number 3. Simplifying complex fractions. So let's say we have 1 plus 5 over y plus 6 over y squared all over 1 minus 4 over y squared. Now, there's a couple different ways for us to do this. One method is to combine all these fractions up in the numerator so that you have a single fraction in the numerator, and combine the fractions in the denominator so you have a single fraction in the denominator. And once we do that, that's a fraction divided by a fraction. I can flip and multiply by the bottom fraction. So that is method 1. That does work, getting a common denominator and combining to a single fraction in the top, single fraction in the bottom. I would like for you to give this other method a chance. This is method 2. Method 2, we're going to multiply by the same number top and bottom, sort of like this fraction right here. I multiplied top and bottom by -1, and it didn't change the value of the fraction, just changed what it looked like. But the key is, what we're going to multiply by is what will help us to clear the fractions in the numerator and the denominator. Now, for example, if I look at the numerator, what would I have to multiply by to clear the fractions? Well, there's no fraction for the 1. I would need a y to reduce with that y. You can write y over 1. That might be helpful to write it over 1. Now, a y would not clear this fraction, so it needs to be more than just a y. It needs to be a y squared. So y squared over 1, if I distributed that to the numerator, it would clear all of those fractions. Now, on the other hand, I told you you can't change the value of the original problem. So if I'm multiplying the top by y squared over 1, I need to multiply the bottom by y squared over 1 as well. Now, let's look at the denominator. Is there anything else we need to clear the fractions in the denominator? Okay, and so no, y squared would clear the fractions in the denominator as well. So the lowest common denominator for all these fractions up in the top and for all these fractions in the bottom is y squared. And so if we're multiplying the top and bottom by the lowest common denominator, it will clear all these extra fractions. Okay, so we're ready to do it. Now, I found over the years that maybe it's a little bit helpful to maybe cover up part of the problem while you're working it. Okay, so if we cover up the bottom half, and if I distribute that y squared over 1, we get 1 times y squared, which is y squared, plus the 5 over y times y squared over 1. One of the y's were reduced. We're left with 5y. And then if I multiply it times the 6 over y squared, the y squareds reduce, and I'm left with plus 6. Now, I'm distributing and reducing. Technically, I'm distributing first, and then we're reducing, even though I'm kind of doing it all in one step. We are distributing first and then reducing. Okay, now we're going to do the same thing here with the denominator. And so if I distribute the y squared over 1, 1 times the y squared over 1 is y squared. And then y squared over 1 times the negative 4 over y squared, the y squareds reduce, and I'm left with negative 4. Okay, so I multiplied top and bottom by the same thing, and it is the lowest common denominator that I multiplied by, and it cleared all the extra fractions. So this complex fraction, a complex fraction is a fraction within a fraction. We've made it into just a rational expression, just a fraction now. So what do we do from here? Well, from here, see if you can reduce it, but you can't reduce until you're in factored form. So let's see if we can factor. Okay, well, the top, y plus 2, y plus 3. And the bottom is difference of squares, y minus 2 times y plus 2. And so the y plus 2's reduce, and we're left with y plus 3 over y minus 2. Okay, now, ultimately, you want to be very good at this method, multiplying top and bottom by the lowest common denominator to clear those extra fractions, because when you have a complex fraction similar to something like this is a much faster way than getting a single fraction in the numerator first, then getting a single fraction in the denominator so that you can flip and multiply. It takes a lot longer to do that. This is much more efficient. Okay, let's do one more example of simplifying a complex fraction. And so here is our fraction, the 3y over y squared minus 4, all over negative 1 over y minus 2 minus 1 over y plus 2. So it's helpful to see things in the factored form. And so y squared minus 4, hopefully you're recognizing that very quickly. That's y minus 2 times y plus 2. So the lowest common denominator for the numerator and the denominator, the thing that would clear all the extra fractions, I need a y minus 2 and a y plus 2 over 1. Now, if I have those in the numerator, I will need this in the denominator as well. So y minus 2 times y plus 2 over 1. Okay, so if we now distribute things, let's cover up the bottom part right now for the moment. Now, it's not really distribution up here in the numerator because there's just a single thing. So we're multiplying. Notice that the y minus 2's reduce, the y plus 2's reduce, and we are left with 3y. Now, down here in the denominator, we are distributing down here. Now, I have to multiply the y minus 2 times the y plus 2 over 1. I have to distribute that to both of these fractions down here first. Distributing first, and then we are reducing, even though we're kind of doing it all in one step. So, if I'm multiplying times the first fraction, the y minus 2 is reduced. I'm left with negative 1 times the y plus 2. Minus. Now I'm distributing it to this part right here, and the y plus 2's reduce, so that's leaving me with the 1 times y minus 2. So we have cleared the fractions, and let's go ahead and distribute the negative 1. It's no longer a complex fraction, but let's distribute the negative 1, and I get 3y over negative y minus 2 minus y plus 2, which is 3y over negative 2y. Now, the top is in factored form, and the bottom is in factored form as well. So, the y's are common factors, and we're left with negative 3/2.